Hi everyone, welcome to another video. In today's video, I'm going to explain how to implement stack using queues. I like this question because it really tests if you are able to think under pressure in interview setup. Even though the problem statement appears simple and easy at first look, once you start thinking about how we are going to implement it, it can create some confusion. In one of my interviews at a big product-based companies, interviewer asked me this question. I spent around 20 minutes to come up with the solution after struggling. In these kind of tricky situations, you should always keep calm and spend more time understanding the problem. Understanding the problem and explaining your approach to the interviewer clearly will help you to arrive at the solution. If you explain your thought process clearly, then interviewer can also give feedback or hints about the approach. Before implementing the solution, let's go through the constraints quickly. We are only allowed to use basic queue methods such as pushing to the back of the queue or popping from the front of the queue and checking whether queue is empty or not. This is important because this makes the problem interesting. Let's understand how can we implement stack using two queues. I'm going to explain this with a diagram. Let's understand how can we implement stack using two queues. We need at least two queues in order to implement the stack. Otherwise it is impossible to implement stack using queue just by using the basic methods of queue. Initially we are going to consider two queues which are going to be empty. One thing that we have to understand about stack is a first in last out data structure. Let's say we push 1 2 3 4 to the stack will look something like this. 1 will be present here, 2 will be present here, 3 will be present here, and 4 will be present here. Even though 4 is the last element that is inserted into a stack, 4 is present at the top of the stack. This is what we need to implement while using the queue. And with respect to queue is a first in first out data structure. If we push the same elements to the queue, our queue looks something like this: 1, 2, 3 and 4, and this is a basic queue. The elements will be processed in the order in which they are entered into the queue. The 1 is entered into the queue first and 1 will be processed first, but in terms of stack that is reverse. So initially both the queues will be empty, and let's say we get an operation push 1. How are we going to implement push 1? In that scenario, if both the Q1 and Q2 are empty, it doesn't matter where we are going to push it. We are going to push it to the first queue and the second queue will be still empty. And when the second push comes, let's say we get an operation named push 2. Here we have to make a decision, because if we push it to the first queue, we get an element order something like this: 1, 2. This is not the stack order because we are only allowed to remove elements from the front of the queue. We cannot get the latest element in one time. So we cannot push it to the stack which already has element. So the trick here is we have to push new element to the stack which is empty. That is the trick here. Push new element to empty queue. That's the only thing we have to follow in order to keep the stack ordering. So here, whenever push 2 operation comes, we know that Q2 is empty. So we will push the new element to the second queue, and then we will copy the remaining elements from Q1. So that is only 1 is present. We get this order Q1 and Q2. So now let's go through one more example. We get push 3. Now we have this state and empty queue is Q1, so we are going to push 3 here, and then we have to copy all the elements to the first queue. The queue will look like something like this. So 3 will be present here. If we copy all the elements from the other queue, we get this order and Q2 will be empty. So this is how we are going to implement the push operation, and the remaining operations will be straightforward. Let's implement the same solution in Leetcode so that you get better understanding of the problem. Let's implement the same solution that we have discussed. The first thing that we need here is we need two queues. So I'm going to declare it here. Both the queues will be of type integers. These are the queues which are going to hold the values for our stack data structure. The first queue I'm going to call it as q1, and we need another queue. I'm going to call it as q2. And after that, this initialization method constructor will not do anything. And let's implement push method for our stack. So whenever a push comes, first thing that we have to check is both the queues are empty. So that is q1.empty and q2 is also empty. If this condition is true, and at that time we are going to push our new element to first queue. So q1.push x. Otherwise, I'm going to check whether q1 is empty. Remember that either q1 will be empty or q2 will be empty. If q1 is empty, then I'm going to push new element to q1 because that will be present at the front of the stack, front of the queue. Whenever we push new element to an empty queue, that will be present at the front of the queue. And after that, we have to copy elements from q2. For that, I'm going to write a while loop. While q2 is not empty, q2 is not empty, we are going to copy all the elements to q1. So q1 dot push q2 dot front, and after that I'm going to pop elements from q2. So this is the second condition. Otherwise I'm going to check whether q2 is empty. If this condition is true, then we have to push the new element into q2 because that will be present at the front of the queue. q2 is empty and we are going to push the new element into q2. q2 dot push x, and after that copy elements from q1. So while our q1 has elements q1 dot empty is false, we are going to copy all the elements to q2. So q2 dot push q1 dot front, and after that we are going to pop it. So this is the implementation of push for the stack. Now let's implement the pop. I'm going to declare a variable named top element and I'm going to initialize it to -1. And after that I'm going to check whether q1 is not empty. If q1 is not empty, then our top element will be q1 dot front, and since we are doing a pop operation on the stack, we have to pop that element q1 dot pop. Otherwise I'm going to check whether q2 is not empty. If q2 is not empty, then our top element will be from q2 front, q2 dot front, and we are going to pop that element from q2. Finally I'm going to return top element. This is the implementation of pop. For the top method, implementation will be very similar to pop, but we don't pop the element. We are just going to return the top element. We are not going to remove anything from the queue. So this is the implementation for top. The last method is we have to return true if our stack is empty. That implementation is very simple. If both are empty, q1 and q2, if both are empty, then we are going to return true. Let's run this solution and check whether it passes the first test case or not. Yes, it is passing the first test case. Let's submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning about other data structures and algorithms, please check out other videos from my channel. Thanks for watching this video.